element of gear hobs to be considered is the number of threads. Although the majority of hobs are single thread, multiple thread hobs have proven their production advantages where job specifications allow their use. Increased production is the outstanding advantage of multiple thread hobs because the indexing speed of the machine is increased in proportion to the number of threads. You can see that the workpiece on the right is rotating 3 times as fast as the one on the left. However, it should be pointed out that some accuracy is normally sacrificed by using multiple thread hobs. Since an error will exist between hob threads, the effect of this error on the gear teeth will be determined by whether the ratio between the number of threads on the hob and the number of teeth on the gear is even or prime. To illustrate the effect of even and prime thread tooth ratios, we have painted the threads on the hob and the tooth spaces on the gear. First, we will look at an even thread tooth ratio. The hob has 2 threads, and the gear has 20 teeth, giving us an even ratio. Thread number 1 on the hob is painted yellow. Thread number 2 is red. On the gear, the odd-numbered tooth spaces are outlined in yellow, and the even-numbered spaces are outlined in red. A reference line on the gear allows you to note revolutions of the work. We have placed the hob and gear on a hobbing machine so that thread number 1 is located in tooth space number 1. When we start the machine, we can see that the yellow thread always falls into the yellow tooth space, and the red thread falls into a red tooth space. This relationship is maintained on all revolutions of the work. Therefore, any error between the threads on the hob is transferred to the gear in the form of tooth spacing error. However, since the same hob teeth always cut in the same tooth spaces, a better profile is obtained than with a prime thread tooth ratio. Now, let's look at the effect of a prime thread tooth ratio. The hob still has 2 threads, but the gear has 21 teeth. The odd-numbered tooth spaces are outlined in yellow and the even in red. This means that 2 consecutive tooth spaces, number 1 and number 21, which are on opposite sides of the reference mark, are painted yellow. We again have placed the hob and gear on the hobbing machine so that thread number 1 is located in tooth space number 1. As the gear and hob start to rotate, we can see the yellow threads fall into yellow tooth spaces and the red threads into red tooth spaces. However, after the first revolution, the yellow threads are engaged with red tooth spaces and the red threads with the yellow spaces. During the third revolution, the yellow threads again engage the yellow tooth spaces. In other words, each thread falls into the even spaces on every other revolution of the work and into odd spaces on alternate revolutions. Since each thread cuts in each tooth space, the effect of any error between the threads on the hob is canceled, resulting in maximum tooth spacing accuracy. However, for the same reason, some profile accuracy is sacrificed. Briefly, these are some of the problems which should be considered when contemplating the use of multiple thread hobs.